Hi, this is Daryl Peterson with Micromeasurements. I'm the manager of the Applications Engineering Department, and I want to take a few minutes and show you a couple of different examples of some full bridge pattern strain gauges. These full bridge pattern strain gauges are intended for taking existing parts and pieces and components and converting them into a transducer. So if you've got an application where you're not so concerned about what the strain and stress levels are, but you're trying to convert that device into a transducer and possibly do it in high volume, this is where you might want to start thinking about these types of strain gauges. Now you'll notice this package is a tray style package. It can hold up to 100 strain gauges in this style of package. The strain gauge that's in this package is an N2A06S5232K-350/E5. Basically, that's a 350 ohm constant tan foil gauge with an E5 encapsulation. The value of the resistance is 350 ohms, plus or minus 3%. And we've got some lot number information and some reference numbers here as well. And it's got a gauge factor at 2.01. So if I take this package and I open it up, very carefully, you'll be able to see the strain gauges that are in there. Now these are just intended to be some examples, but if you look closely at it, you'll see that this gauge has 4 sensitive grids. These 4 sensitive grids are all wired into one circuit, and that one circuit presents a 4-tab full bridge into electronics. So when you think about taking, for example, like a small beam and bending and making it into a transducer, you only have to install one of these onto that beam, and then you're going to connect 4 wires. Those 4 wires are going to be 2 for power to power the Wheatstone bridge and 2 for reading the signal off. Very common application. Typically, we see these gauges used whenever you're trying to construct a low-cost bending beam style transducer. So very common, very typical application for that. Now let me show you a couple of others. The next one is an N2K06S5107Q 12C/DG/E5. And basically what that means is that the 12C, it's a 1200 ohm strain gauge with a tolerance plus or minus 0.2%. It's got the N2K construction. I already know it's a full bridge. In this case, again, this sample packaging is 100, could have up to 100 pieces. That's a foil lot number, a reference manufacturing number, and then the gauge factor at 1.89. So if I take this package and gently open it up, you'll see another full bridge strain gauge. Again, 4 tabs, constructing a full Poisson bridge. This is another configuration, sort of similar to the first one in that it's a 4-tab construction, 4 sensitive grids. Now the resistance, instead of being 350 ohms, is now 1200 ohms. And we've got the 4 tabs, 2 for power and 2 for signal. So again, if you've got a part that's maybe being loaded and bending, maybe you're trying to build a low-cost bending beam type transducer, this might be the type of strain gauge that you would select because, again, your entire circuit is complete right there on the gauge. So all you have to do is focus on cleaning that surface, getting the gauge installed and wiring it, and then you're off to the races because at that point you'll have a small transducer. I can reach in here and take this one gauge out. Try to handle it by the backing and down near the tabs. And again, there you can see it's got 2 grids. It's got 2 grids in the axial direction, 2 grids in that transverse direction. And if I flip it upside down, you'll see the dull side, right side up. You'll see the shiny side. Okay, let me show you one more. Let me close that up and show you one more. This last one is an N5K MC S5263Q-20C/DP-M5M3. Now that's a lot of letters and numbers. But basically what that means is that it's an N5K construction, which is associated with a higher temperature. The MC means it's modulus compensated. So that's one of the options we can add to strain gauges, where we adjust the foil so that it matches a modulus variation of your material. This particular mod comp happens to be an M3. The S5263, that's the pattern. I'll show you that in just a second. The 20C means that it has a resistance of 2,000 ohms. DP means that it's got some copper or gold on the tabs. E5 means that it's encapsulated with the E5 overlay. Tolerance on the resistance is 3%. Strain gauges are, it says 5 per pack, but this is an example of a larger tray packaging. We've got some foil lock control numbers, some reference numbers for manufacturing, and then a gauge factor, which says gauge factor is 2.16. Now, if I take this package and open it up carefully, and we look at one of these gauges, if you look at it closely, what you'll see is this one now actually has grids at plus and minus 45. This is a 4-tab full bridge gauge for measuring shear. So this would be if you had some type of tube or member where you're trying to calibrate it for torsion. Now you could consider using one of these. It's a 4-tab strain gauge, 4 tabs meaning 2 for power, 2 for signal. It's got 4 sensitive grids on it, all constructed into a full Wheatstone bridge configuration. And now you would take this, install it on your structure. All you have to do is focus on getting it wired, getting it bonded correctly, put some environmental coating on it. And from those wires, you'd run those back over to your data acquisition system. And basically, you could calibrate this now for torque. Pretty typical application. And one of the unique things about these gauges and this advanced sensors technology that we're using is that we can make these gauges in much, much smaller sizes and much higher resistances than ever before. 10 years ago, we couldn't make a gauge this size in 2,000 ohms of resistance. It just wasn't possible. But now with the advanced sensors technology, we can build gauges even smaller than this and even in much higher resistances, all the way up to easily 10,000 ohms. So if you've got an application where maybe power consumption is a primary concern, you start looking at these advanced sensor gauges, and that's one of the ways to reduce the power consumption. Maybe it's a device that goes on a product where that device is battery operated. That's when you want to start thinking about using these higher resistance gauges to really reduce the amount of current draw. Or possibly you've got some long lead wire connections connected into the circuit for whatever reason. That's another reason why you would start looking at these higher resistance gauges as well. It'll help to reduce the influence of the lead wires in the measurement. So that's another example of a full bridge 4-tab version. This one happens to be for a torque measurement. I'm going to close this package back up. If you'd like to find out more information about these types of strain gauges, these transducer style strain gauges, again, one's intended for building transducers, please feel free to take a look at our website at www.micro-measurements.com, or pick up the phone and call us at 919-365-3800 and follow the prompts till you get to applications engineering, and we'd be happy to help you. Thank you and have a good day.